Alrighty, so this is going on page 123 when we're done. And we're starting the polar coordinate system. We are not done with trig, because if you look over on that board over there, that is polar. It's a calculus problem, and it's a polar problem, but obviously there's all that trig within it, right? So we are not done. It's all intertwined, and we'll get there real quickly, okay? So this says, up until now, you have graphed on a rectangular plane containing an x and y axis. So that's your xy axis, your two-dimensional coordinate plane, your Cartesian coordinate plane, the stuff you've been graphing on forever. We will now look at another coordinate system called the polar coordinate system. And it's not that it's the only other one. There are multiple ones. We will look at some other ones at the end. I'll kind of give you a little overview. But let's talk about the differences between these two real quick. So if you, up here, I want you to draw an x and y axis. I'm going to draw another one. So this one, we're actually going to label that this is y, this is x, okay? And we're going to plot the point 2, 2. So this point right here would be like point 2, 2, right? Super easy to graph. We started 0, 0, go to the right 2, go up 2. And then, so to get there, we went to the right 2, then we went up 2, right, which makes this perpendicular. And if we connect these two, we have a little right triangle. What would the hypotenuse be here? What kind of triangle is this? You shouldn't have to do any work at all. Y'all are making me really sad right now. Oh. It's 2 square root of 2. It's a 45, 45, 90 triangle. It takes 0 work. 2, 2, 2 square root of 2. Well, I didn't hear you. I talk louder. What is this angle right here? 45. It's a 45, 45, 90 triangle, right? Sort of, yes. Okay. Yeah, but you were doing way too much work. You should just know it. Okay, so that gives us this point right here, right? And so the polar coordinate system, it's not that it gives us a different set of points or a different kind of graph. In the end, if we graph something in the rectangular plane and graph the same thing in the polar coordinate system, if we put the two graphs on top of each other, they look identical. So it's just a different way to get to the same place. And depending on what we're doing and what we're applying, one might be better than the other. And right now, you're not going to have to decide which one is the best. You're just going to be told, use this, and then we'll kind of get there. So if this, and this isn't exactly what the polar coordinate system looks like, but I'm not going to put an x and y on there because that's not what's actually happening. Instead of going to the right and going up, like these two coordinates right here, in the polar coordinate system, you go out a distance and then you rotate around. So this 2 square root of 2 is what I'm actually interested in. So if I go out 2 square root of 2 and then I rotate, I can get to the same point, but I got there by using this length and this angle right here. Okay. Does that make sense? So instead of going to the right and going up, you go out and you swing around your angle. Yes, sir?
So basically using the x-axis as the hypotenuse.
Well, not exactly. I wouldn't go there. No, I bet there's no x-axis. So we'll just hang on a second. So do you see how if I took those two graphs and put them on top of each other, that point would be in the exact same spot? I'm just going about it a different way of getting there. Okay, just kind of like getting to a point on a track. You know, I could walk to the right and I could walk and get directly there, or I could, you know, go out a distance and run around or whatever. But there's just two different ways to get there. Okay, so our polar coordinate system over here, we don't have an x and a y axis. I know I drew it like that right there, but that was just so you could kind of match the thoughts together. It says you fix a point O called the pole or origin. Right? And you can call it either one. Really, we call it the pole. And somebody last period said, well, what will other teachers call it? I think most everybody that's going to talk about polar calls it the pole. But if you see it referred to as the origin, it's still the same thing. So instead of having an x and y axis, which are two lines that are perpendicular to each other, you only have a ray. So it says, from O, construct an initial ray called the polar axis. So the polar axis is not like the x and y axis. This is the pole, and this is the polar axis. So if you want to think of it like the x and y axis, the only part that exists is what would be kind of like, but not exactly like, the positive x-axis. Like that is it. There's no perpendicular lines there. So this gives you a distance, and then you swing around an angle so that you can get to point P. Why is it called a pole? Because it's like the center that everything rotates around, because it's polar? Because it's rotation? You rotate around a pole? All right, so each point P in the plane is assigned a polar coordinate. So instead of x, y, your ordered pairs are r, theta. Okay? R is the directed distance. You can think of it like the radius of the circle that you would get if you rotate that point. So R is the distance from O to P, right? And then theta is the counterclockwise directed angle formed by the polar axis and this line segment. And this should have a line segment above it. Now, you can have a negative R. So when R is negative, instead of graphing r theta, we graph positive r and then theta plus pi. And we'll talk about that once we get to one of them. Okay. Everybody good so far? So let's plot some points and see how they get plotted in a polar coordinate plane. So this is what basically your polar graph paper looks like. Again, you only have, this is the only axis that exists. So it says concentric circles are frequently shown on the polar coordinate system. Concentric meaning they have the same center. Remember, con means with, like queso, the only Spanish I know, with cheese. Right? So graph and label each point. So let's look at number 1. This point A is 2, 7 pi 6. So I go out to 2 on my axis, and then I rotate around to 7 pi 6, and that's my point right there. Okay. Easy enough? All right, so then B is 0.5, 3 pi 4. So here's 1, so here's 0.5, and then I rotate around to 3 pi 4ths, which is right there. Sorry, I have to stand in front of it or I can't keep up with the lines right. All right, we all good so far? Yes? All right. So then we have C, which is 3 and then negative pi thirds. So I go to 3, and then I have to rotate a negative pi thirds, which gets me down here, and this is C. All right, so now we have one with a negative r, right? And so in order to do that, we actually plot r, meaning the positive one, and then we do pi fourths plus pi. So let's look at that. If I go to 1, and then I'm going to rotate to pi fourths, what is pi fourths plus pi? 5 pi fourths. So I want you to see that when you do that, it's on this same line that would go through this like this, right? So if I go to 1 and then I go to pi fourths, if I'm supposed to be at pi fourths plus pi, I rotate around here. But you don't have to actually rotate. Another way to think about that and look at that as you graph these is if I go to 1, a pause, because there's not a negative anyway. So I go to 1, I rotate to pi fourths, and I just pass through the pole, then I'm there. That makes sense? Passing through directly through the pole is the same as going around another half of a rotation. Okay, so that's kind of the easiest way. You go to the radius, you rotate to what it says, then you just pass through the pole and make that point. Okay, so this is D. What makes it negative? That you're adding the pi to it. There's not a negative 1. There's not a negative on the axis. It doesn't exist. Yes, sir? Kind of, yes. Mm-hmm. Yes, exactly. Very good. All right, so number 5, let's see. We've got negative 2.5 and 4 pi thirds. So I'm going to go to 2.5. I'm going to rotate to 4 pi thirds, which is right here. And then I'm going to, because it was a negative 2.5, I'm going to pass through the pole, and I end up right here. And this is E. Okay, we all good? All right, y'all do number 6. Yes, but like the funky, yep, we're getting there. There's some really crazy graphs in Polar. Yeah. Okay, so on number 6, I'm going to go to 3. I'm going to go to negative pi 6, which is right here at 11 pi 6. Then I'm going to pass through the pole, and my point ends up right there, and that is F. Okay? We all good with that? What questions do we have? Nothing? We can plot these points? Yes? Okay. So now this next set of things is one of those wording things which can seem a little wacky at first, but it says, while each pair of polar coordinates plots a unique point, each point does not have unique coordinates. So what that means is, just like when we plotted these points, there's only one place that I can plot this point. That's it. When I plot that, it's there. That's the only right answer. However, if I were to take a point off of the graph and ask you what the ordered pair is, there's actually an infinite amount of answers because you can rotate, in either direction. Does that make sense? So you have tons of ways to get to that point, but if I give you a point, there's only one that exists. So that's what that means. It sounds a little weird. So anything, if you have a point that is r theta, you could also represent that by r, comma, theta plus or minus, and then of course we're rotating 2 pi to get there, 2 pi n, and it says at the end where n is any integer. Or if r is negative, so it'd be negative r, comma, theta plus or minus 2n plus 1 times pi. And honestly, that little thing right there, I mean, that's mathematically how you get there, but really you don't even have to think about it that way. Okay, to me it's easier to think about where the point is and come up with those. Now, we're going to be asked for other ordered pairs. There are an infinite amount of answers, but they're restricting our domain. So from negative 2 pi to 2 pi, there's only going to be a total of 4 possibilities that you could give. So there's one they give you, and then there's going to be 3 more that we come up with. Okay, so that's why it asks for 3 different pairs. So here's how we can think about this. We've got, here's this, I always draw a picture so I can think about where this actually is. And so 2 5 pi thirds, so you can just pretend like your radius is 2 because it can be whatever you want. And then when you go around to 5 pi thirds, that is in the 4th quadrant, so we're right here. Okay. And can pass through the pole like that. So this particular point that I want to plot, this ordered pair gets me there, right? What do you think another possibility would be to get me to that same spot? 2 negative pi thirds, okay. 2 negative pi thirds, do y'all agree with that? Yes, okay. Then I'm going to have 2 more. Okay, so negative 2 2 pi thirds, because I would go to 2 pi thirds and then pass through. Okay, so I'm good with that. Negative 2 2 pi thirds. Then what? Negative 2 negative 4 pi thirds. What do y'all think about that? Because I'd go negative 4 pi thirds and then pass through my pole, right? And that's why that picture helps me, so I can make sure I've done them all. But I want you to notice what you have here as far as our answers. We have 2 that have a positive r, I mean including the one they give me, 2 that have a negative r, and then each one of those has a positive and a negative angle that goes with it. Right, so you kind of know what other ones you need to fill in that you don't have, and you can kind of start off that way as well. Also notice the r value, whether it's positive or negative, the absolute value of it, it's the same number. Like that's not going to change. It's the angle that changes to get you there. Okay? What questions do we have?
So if you want to know all 4, you just use the same one, those are all the 5 thirds.
You just got to make sure you get the positive and negatives right, and they match them up correctly. Yep. All right, so let's look at number 8. Okay? So let me draw the picture in here.
So there's 4 because you go around the circle.
No, because you can go in either direction. Because you're going from negative 2 pi to 2 pi. So you're only going around the circle once in either direction. So once is clockwise, once is counterclockwise. So you're going around twice, but not like 2 in a row. Does that make sense? Okay. All right, so here I'm at negative 5, negative 7 pi fourths. All right, so negative 7 pi fourths puts me in the 1st quadrant, and then the negative 5 means I'm going to pass through. I'm actually in the 3rd quadrant, so I'm looking at this. So before you even think about what the actual answers are, you can fill in some stuff on here, meaning that this is a negative radius, so I'm going to have another negative 1, Then I'm going to have 2 positive 5s. And of those 2 positive 5s, one of them has a positive angle, one of them has a negative angle. And since this is a negative angle, this one has to be positive. Does that make sense? Then you can make sure that you have all of your combinations. You don't have to do it that way, but it's totally up to you. All right, so then let's look at this. So if I'm going to use the negative 5, that means I actually end up here. So instead of going negative 7 pi fourths, what could I do to get there? Positive pi fourths. Then if I'm going to have a positive radius, that means I go directly here, and I can get there how? 5 pi fourths and negative 3 pi fourths, exactly. Okay. What questions do we have? All right, so I'm going to give you a minute. I want you to do number 9 on your own. Yeah, go ahead.
Do they, like, so for the pi thirds, it went 1 pi is negative, 2 pi is positive.
No, it depends on, that's not going to be a pattern there. Yeah. Okay, so one possibility would be negative 1.5, negative what? 11 pi 6, good. Then I could have a positive 1.5 and a positive what? 7 pi 6. Then a positive 1.5 and a negative 5 pi 6. Okay. What questions do you have? We're good? Yes? Okay, awesome. So here's where we're going to stop right now. The rest of this you have to watch that video for so that I can give you time for your test. All right?